I will now use our sample program and modify it to create and call an additional function. I first will need to create a prototype for my function. This will be a void function, and the purpose of this function is to calculate the results. So I've created a function prototype. The calling statement will go in place of the current statements that are causing the actual calculation. So I will call this by simply using the name of the function, calculate results. And for the time being, I will simply leave it as the open parentheses. The third component is, of course, to create a function definition. So I'll go below at the very bottom of the program and create this function definition. I have created a shell of sorts for this calculate results. Rather than retyping this code, I can simply cut and paste the calculations that I want. The calculations are in the main program. So I will cut these to remove them from the main function and place them into my function definition that I've now created. Now, the only difference to this program is that the placement of the calculations have been removed outside of the main function and into this programmer-defined calculate results function. Now, our next task will be to compile this program to see if it actually works. I'll warn you now that there is a problem with this program. We click on Build. You'll notice that the compiler tells me that 3 errors have been generated. If we scroll up to the top one, in fact, you will see that each one of these error messages refer to undeclared identifier. And the identifiers in question are number squared, number input, and number halved. If I double-click, it's taking me to the statement that I cut from the main function and placed into this programmer-defined function. The problem here has to do with the scope of the variable themselves. The way I've modified this program is these variables are outside of the main function. The definition of these variables, however, remain in the main function. And this is the problem. C could not recognize the variables since they are declared outside of the main function, or since they're being used outside the main function. A variable scope indicates which portions of the program can use the variable. The scope, which can either be local or global, is determined by where you declare the variable in the program. Variables which are called local variables are declared in a statement block, which is simply a group of instructions enclosed in braces. Global variables, on the other hand, are declared outside of any function in the program. Unlike a local variable, which can be used only by the function or the block in which it's declared, a global variable can be used by any statement that follows this declaration in the program. You should, however, avoid using global variables. If more than one function needs access to the same variable, which is the case in our example, it is better to create a local variable in one of the functions and then pass that variable only to the other functions that need it. And this is what we'll do to correct our program. Since my function requires the use of number squared, number input, and number halved, when I call this function, I need to pass these variables to it. So, returning to the calling statement, I will insert inside the parentheses the variables that I wish to pass to this function. I have typed number input, number squared, and number halved, separated by commas, inside the parentheses. Now when this statement is called, or this calling statement is executed, these 3 variables get passed to this function. Now there's one more piece of business that needs to be taken care of, and that is that the function definition needs to accept these variables. So I need to include in parentheses these variables so that they will be accepted into this function. In the function header, you must declare the type of variable that's being passed to it. In our case, all variables are float. So I'll simply type float, the name of the variable, separated by a comma, and then I do likewise for the remaining 2 variables. Again, preceding each with the keyword float. And of course, make sure that you're spelling the variables in a consistent manner. Now changed our function header, we also need to change the function prototype. Our function prototype currently simply says there is a function called calculate results, but the prototype does not have the information that C needs in order to process this data that's being passed to it. You do not need to tell C the exact variables, but you do need to tell it what type of variables to expect. In this case, we are passing to it 3 float variables. So we simply need to type float 3 times to represent that each variable that's being passed to this function will be of type float. Let's compile our program to see where we stand. As you can see, it returns no errors, no warnings. We'll now run our program. Once again, I'll enter a number. I'll enter the number 7. As you can see, the program is run, but our answers are now 0. There is one additional modification we need to make to this program, and I will demonstrate this in the next segment.